Hmm. Hello, evening, guys. Happy Wednesday. Happy July. This is our July week one. How are you guys doing? How are you guys doing? Uh, it's the second half of the year. Do you realize this? How am I? I'm good. I'm good. Kavi, thanks for asking. How are you? Uh, this is the second half of the year. So, I'm okay. I'm okay. Kavi, don't worry. I'm okay. I'm much better now. Okay, guys. Are you ready to learn today? You want recap? Yes, sure. I will. I shall do that for you. So, guys, before I move on, let's recap on last week. Okay, let's recap on last week. Oh, in fact, right, I'm gonna do some exercise before we move on. Would that be good for you, Gavi? Would that be good for you? I'm gonna do some exercise. Okay, so I will make sure you are okay with this chapter first. So last week we did mention what happens when you do electrolysis, isn't it? Remember, what is the first thing you do? Look at the water and find the word whether you see solution. Remember? Solution. When you see solution, that means this thing has water. Remember? And what am I doing? I need to split sodium and sulfate. I need to split H and O. Boy left, girl right. Boy left, girl right. Boys are always on the right side, left side. Girls are always on the right side. Remember? Remember this? So I have two guys swimming in the water in the swimming pool here. I have two girls swimming in the swimming pool here. So I need to choose one guy and one girl and kick them out of the pool. Do you remember? I need to choose one guy and one girl and kick them out of the pool. So who do I choose? I choose the ugly ones. I choose the bottom three. I choose the bottom one. Okay, the ugly one. So now hydrogen will be chosen. Hydroxide will be chosen. So in this case, hydrogen will turn into hydrogen gas. Hydroxide ion will turn into oxygen gas because hydroxide is an O. Okay, it will turn into oxygen. Remember this? Remember this? And do you remember what is your cation and cathode? Cation is your positive ion. Cathode is your negative stick. Cation goes to cathode. Anion goes to anode. So anion is negative, anode is positive, so they will go there. Remember this? Guys, do you remember this? I hope you do. I hope you do. And this is what we call our situation one, our condition one, situation one. And then there's situation two. There is situation two, which in this case, they tell you something about this, which I told you, this is the concentration. Remember, 1 mole decimeter cube is the concentration. Remember this? 1 mole decimeter cube is the concentration. That means how concentrated the water is. Okay, and then same thing, solution is H2O, sodium chloride, and water, you split into two, so positive, negative, positive, negative. So we have two guys in the swimming pool. We have sodium ion and hydrogen ion. We have two girls in the swimming pool. We have chloride ion and we have hydroxide ion. So when they say concentrated, when they say 1 mole decimeter cube, there's a slight change in the rule. Remember, usually we choose the ugliest guy and we choose the ugliest girl. But in situation two, the guy we keep choosing the ugly one. But for the girls, we choose those in the red color box. Remember, I will choose the one slightly higher, which is chloride, bromide, iodide. I still wouldn't choose the top three. You remember what I mean? You remember what I say? No matter how concentrated, I won't choose these three because they are too pretty. They are too pretty, they are too tall. We will choose the not so pretty one instead. We will choose slightly higher. Since it's concentrated, I choose higher, but not too high. Because these three too pretty. Can? Guys, are you okay with this? Are you okay with this? Do you still remember this? I hope the holiday doesn't make you forget things. Jella, Charlene, are you guys okay? Are you guys okay? I realize the holiday has done some horrible stuff to my students. Everyone is freaking blue, right? Oh my god, Monday class, my god, the blue is crazy. Everyone is like half dead. Should I say half dead? Everyone is half dead, right? So please don't be half dead. Okay, and then the situation 3, I'll talk about this later. Okay, I'll talk about this later. Okay. Jala, are you there, Jala? Are you okay? Situation 3 later lah. We'll talk about the exercise. Okay, let's go to exercise, shall we? Let's go to the exercise K. Wow, so敷衍. Okay, at least type okay lah. Hello. Okay. Have we done question 17, guys? Have we done? Oh, we have done question 17, which is our page 7. Sorry, question page 17. We have done question 5, right? We have done this, right? Have we? Have we? Told us to do. Okay. Have I give you the answer? No, not yet. Okay. I'll give you the answer here. Okay, so what is meant by electrochemical series? I did ask you guys to do this. So if you guys didn't do, then I cannot do anything lah. Okay. Guys, this chapter requires a lot of practice. You don't practice means you cannot do. Okay, so question 5. Okay, question 5. So we have 2 sets here. They are separate. Okay, they are not together. What is the electrochemical series? Guys, this good looking chart, the guy's good looking chart and the girl's good looking chart, this is what we call your electrochemical series. In short, I call it ECS. All right. What is the meaning of the ECS? It's the ranking system. So you don't need to know the definition. They are not asking this for exam, so I'm going to skip. Right? But if you must know the answer, your ECS is... Oh, it's not even mentioned here. Okay, it's an arrangement of cation and anion according to their reactivity. Right? If you must know the answer. Okay, I don't care. Right, guys, let's look at the first situation. Sodium nitrate solution. Sodium nitrate solution. When you see solution, what do you do? What do you do? You write H2O. Okay, you write H2O. So what do you do next? You split plus, minus, positive, negative. So I have 2 guys swimming in the pool. I have 2 girls swimming in the pool. You see, it's the same thing. So they want the ions present in the electrolyte. I'm going to split it to positive, negative to make your job easier. So we have sodium ion. Remember to write ion. Remember to write ion. And you have hydrogen ion. On the negative side, we have nitrate ion. We have hydroxide ion. Remember, your O is not oxygen. If it's in water, as in H2O water solution, water, we call them hydroxide. Oxide and hydro. Hydro is in water. So now what do we do? What do we do? You see, anode. What is anode? Another. See, another. Another is positive. Okay, positive will attract negative. And negative will attract positive. Okay, yes, hydroxide will be chosen. So hydroxide ion here. And hydrogen will be chosen. Hydrogen ion here. Guys, do not confuse with the direction. Do not confuse with the direction. Many of my students, they got this in reverse. Okay, that is a very wasteful way to lose your marks. But guys, this 2 answer is actually wrong. You know why? You know why? They don't want the ion. They want observation. They want observation. So hydroxide ion is not an observation. You cannot see hydroxide. Guys, what will hydroxide turn into? We learned this last week. What will O turn into? What will hydroxide turn into when they got kicked out of the pool? What do they turn into? What gas do they turn into? I'll give you a hint here. It's a gas. What gas they turn into? Yes, they turn into oxygen gas. Hydrogen, it will turn into hydrogen gas. But this is still not the answer. Because you see, you cannot see oxygen, you cannot see hydrogen. They are transparent. So what do you see instead? When you see hydrogen coming out here, when you see oxygen coming out here, what do you see? What do you see when you have gas in water? Yes, bubbles. This is the true answer. Both sides also bubbles. But different bubbles lah. One is the oxygen bubble, one is hydrogen bubble. But they don't care. They don't care. They just want to know what you see. They just want to know what you see. Not oxygen, not hydroxide, not hydrogen, not hydrogen ion. You see, that's why guys, sometimes the difficult part about this chapter is to read the question properly. What do they want? If they ask for the ion, if they say here ion instead, then you give the ion. If they ask for the product, you give the gas. If they ask for the observation, then you need to write what you see. Confusing, isn't it? Confusing, isn't it? This is the ion. This is the product. This is the observation. Please kindly understand the difference. Okay, not too difficult. It's just a bit confusing here. So next, copper nitrate solution, H2O. Okay, we split this into two, plus minus, plus minus. Okay, again, plus minus. So we have two guys swimming in the pool. We have copper ion. We have hydrogen ion. And then we have nitrate ion. We have hydroxide ion. Okay. Yes, Kami, what's up? What's up? So hydroxide ion will come here. Same thing as up here, you will still see bubbles. What is NO32? Don't care. Ask your chemistry friends to explain it to you. No. That is not your job. That is not your job. We will never deal with this. We will never deal with it. This is not your job. Don't bother. Right, guys, I have a question here. Who will be chosen here? Who is uglier between copper and hydrogen? Who is uglier? Copper, Copper is uglier, Copper is uglier, not hydrogen. So copper will be chosen here. Copper ion will be chosen here. Okay, guys, what is copper? What is copper? Is copper a gas? Is copper a liquid? Or is copper a solid? What is copper? Yes, copper is a metal. This thing will become copper metal. But guys, they don't want the product. They want the observation. What do you see? What's the color of copper? What's the color of copper? The color of your wire, isn't it? This is your copper. Yes, bronze. What color do you call this? Guys, how do you describe this color? If someone has never seen copper before, how do you explain this color? Brown red. Kavi, you don't need to precipitate. Your brown red is correct. Okay. Well, Kavi, that's very good. That's very good. Okay. So what do you see here instead? What do you see here? Copper will come to negative and it will stick here. So what do you see is, you will slowly see brown color stuff stick here. You will slowly see copper stick here. All right. So how do we describe this? How do we describe this? We say reddish brown deposited. Reddish brown deposited. What does it mean by deposited? Deposited means they stick there, melekat. Okay, your perang is brown lah. Perang kemerahan melekat. Okay, the thing sticks there. Reddish brown deposited. Can? Guys, are you okay? Are you okay? I'm talking about an observation here. I am talking about an observation here. I am not asking for any ion or any product. No, I only talk about the observation. So please know the difference. Okay, know the difference. So see what are the products are now they are asking for it. Can you just write stick? You can lah, but stick is gonna be really, it's gonna be a really funny answer. You want you write lor. But it's gonna be really funny. Okay, so for the sodium nitrate, for the first set here, for these two, what is the product at the anode? What is the product here? Which one is the product? You don't want. What do you mean you don't want? Depositor sounds okay, what? Okay, what's the product here? Which one is the product here? Which one is the product here? They want sodium nitrate, this one, this set, at the anode, anode. So what is the product here? Yes, that's your oxygen gas. Okay, oxygen gas, that's the product. What is the thing that is coming out? And then cathode here, what's the product here? What is the product here? The product here would be your hydrogen gas. Hey guys, please write gas. Please write gas. If you just write oxygen, your teacher will give you wrong, because oxygen can be an ion, can be a gas. Hydrogen can be ion, can be gas. So they want, which one is it? So please be careful here. Okay, please take note here. So oxygen and hydrogen, you guys okay? You guys cool? You guys cool? Okay, so guys, moving on. Moving on. So what are the ions selected to be discharged? Okay, discharge means they kicked out lah. At the anode during electrolysis of copper 2 nitrate solution. Copper 2 nitrate solution is this one. So at the anode, what ion is chosen here? Now they want the ion. They don't want product. They don't want observation. They want the ion. So what ion is here? What ion is here? For this set copper nitrate for the anode, what ion is here? Anode, Kavi. Anode is positive. What will they attract? What will they attract? They will attract the negative hydroxide ion, isn't it? Yes, hydroxide ion. So hydroxide ion. And they want you to explain why choose this, why not nitrate, why hydroxide? Because in the electrochemical series, they are hydroxide is what's the position like? Describe me the position. Hydroxide is what? Electronegative is up here. Electronegative is going up. Okay, if you don't want to say, if I don't want electronegative, I'm going to keep it simple. Hydroxide is lower than nitrate ion. Okay, so you can say it is lower in the ECS. Right? Hydroxide is lower in the ECS, so we choose the lower one. Can you want to write electronegative, right? You say less electronegative. Electronegative means good looking, pretty. Electronegative means pretty. So hydroxide is less pretty than nitrate, right? So hydroxide ion is less electronegative than hydroxide. Sorry, than nitrate. You get what I mean, right? You get what I mean, right? Okay, so next. It's a similar question. What are the ions selected to be discharged at the cathode during the electrolysis of copper nitrate? Okay, just now copper nitrate is this guy, right? The anode, we will choose hydroxide. What about the cathode? What ion is being chosen here? What ion is being chosen here? So Kavi, that was your answer. That was your original answer for just now. Yes, that would be your copper ion. Right? That would be your copper ion. Again, explain your answer because it is lower in the ECS. It is less electropositive. Okay, just now it's less electronegative. Now it's less electropositive. Okay, any of you writing in BM here? Any of you writing in BM? If no one is writing in BM, then I'm not going to bother. Huh? If you're writing in BM, please let me know. Okay, so next, complete the conclusion for the experiment. The ions at the lower position of the electrochemical series will be selectively discharged. Lower in the ECS will be kicked out. That's how I just say lower will get kicked out. Please don't say kicked out in your exam because that's not the proper word. The proper word is discharge. Okay, the proper word is discharge. Okay, cool. Cool. Should be okay, huh? Should be okay, huh? Should be no problem, huh? Should be pretty simple. Okay, I mean, this part, this chapter, I say it's the hardest chapter in Form 5, right? Yes, it is the hardest chapter. But after my effective way, oh, is it a comment? Is it effective? After my effective way, this should feel confusing. It's not difficult, guys. It's not difficult. It's just a bit confusing. That's all. You just choose the ugliest guy and the ugliest girl, then the problem is solved, isn't it? That's basically behind it. Okay, so let's go to question 6. Let's do one more. Let's do one more. Okay, what do you see here? And what do you do now? What is the first step, guys? What is the first step? What is the word you look for? What is that word you are looking for? That cup of water. Yes, solution. H2O, good. So what are we doing now? We cut. Positive, negative, positive, negative. 2 guys swimming in the pool, 2 girls swimming in the pool. Okay, so state all the cations present in the electrolyte. All the cations. Guys, is cation positive or negative? Is cation positive or negative? Just in case you forget, right? Just in case you forget. Cation goes to the cathode. Anion goes to the anode. Cathode is negative. So cation is positive. Okay, so they want you to state all the guys. Cation are the guys. Who are the guys in the pool? Who are the guys in the pool? Yes, you have your sodium ion. What else? One more. Who's the other guy? Who is the other guy? Hydrogen ion. Good. Charlene, did you do this part? And Jala, did you do this part? Did you guys do this? Yes or no? I mean, don't be shy if you didn't do this. Which I recommend you do lah. If you don't do, I cannot do anything. It's Na sodium. We don't write Na. We don't write Na. Kavi, we don't deal with symbols because that is for chemistry. Unfortunately, that is for chemistry. Because in chemistry, they don't write sodium ion. They just write Na plus. Their job is easier. but they learn much harder things lah. So this is the trade-off lah. So we don't write an A plus in exam. This is not our syllabus, so it will not be accepted as well. Okay, everyone okay here? Is everyone okay? Where the hell is everybody? Why is there only 3 of you today? So number 2, state all the anions present in the electrolyte. So who are the girls here? Who are the girls here? You have your nitrate ion, good. And you have your hydroxide ion, good. Can understand? So which electrode act as the anode? Who is the positive? Another. Who is the positive? It's even labeled here. Come on. Yes, that's your P. Remember, it's always connected to the long side of the battery, the positive. Okay. So C, name the ions chosen to be discharged at electrode P. Who is chosen here? Who got kicked out here? Who got kicked out here? Okay, if this is confusing, positive will attract who? Positive or negative? Negative, right? Negative, right? And who will be chosen? Who will be chosen? Yes, Kavi, you got it right. That's your hydrogen. Sorry, hydroxide ion. Is this the answer? Yes, because it's ion. Ion. They are not asking for the product. They are not asking for the observation. Okay, they are asking for the ion. What about electrode Q? Who is chosen? Who's the uglier one? Who is the uglier one? The uglier one is the hydrogen. Yes? Ken? Are you okay? Yes, cool. Same question. This is, if you can do this, I don't see the reason why you cannot do this. You see, it makes no sense. You can do the same question, but not the other same question. Right? So explain your answer in C2 based on the selection of the ion. Why choose hydrogen? Like I said, they are lower in the ECS. Okay? Lower in the ECS. They are less electropositive. Because this guy is positive. It's less electropositive. Okay, so let's do one more, shall we? Let's do one more. Question 7. So I have 2 sets here. Okay, Kavi, did you do this? Any of you here do this? Any of you here did this? This question is a bit funny. Okay. What does set 1 and set 2 tells you? What's the difference between these 2 sets? Like I said, when you see 1 mole decimeter cube, what's the meaning? What's the meaning? Yes, highly concentrated. This is situation 1 or 2? Situation 1 or 2? Situation 1 or 2? When it's concentrated. Kavi, are you sure? Are you sure? Concentrated is situation 2, Situation 2. Oops, sorry. Situation 2. Right. What about second set? What about second set? What does it mean by 0.001 mole? Is it concentrated? What is less electropositive? Okay, Kavi, electropositive is good looking. Electronegative is good looking. Both are good looking. But positive is for guys, negative is for girls. So less electropositive means less good looking. Less electronegative means less good looking also. But one is for guys, one is for girls lah. Okay. If you don't understand, then don't write that. Okay, it's okay. Guys, 0.001 mole decimeter cube. This one, is this, what situation is this? Is this situation 1 or 2? This is 0.001. Is it concentrated? Is this concentrated? No, right? No, no. So what situation is this? This is 1. Okay, this is situation 1. Can understand? You understand? Okay. You mean why, Kavi? You mean why? Because 0.001 is nothing. Why do I keep opening this? Okay, 0.001 is nothing. Like not concentrated, just like any other solution. Right? Basically, when you see 0.001, you can ignore. You can just ignore. All right. So let's talk about what is inside here. Okay, so what water do they use this time? They use hydrochloric acid. I have a question here, guys. I have a question here. Is this a solution? Is this a solution? Do you have water inside hydrochloric acid? Yes. So this guy has H2O also. So we do the same thing. We do the same thing. Hydrochloric acid, cut, H2O, cut, positive, negative, positive, negative. So we have 2 guys swimming in water, 2 girls swimming in water. The SOP still runs. We still do it as normal. You might say, hey sir, isn't hydro and hydrogen the same? Yes. That means in this swimming pool, there's only 1 guy. Guys, pay attention here. Pay attention here. In this swimming pool, there's only 1 guy. Because both guys also hydro. Hydrochloric acid is hydro. H2O is also hydro. Both hydro. Okay? And then the girl is chloric, the chloride, and oxygen, the oxide, the hydroxide. Okay, the hydroxide. So state all the ions present in hydrochloric acid. You have your hydrogen ion. There's only 1 guy here. And then you have your chloride ion. Okay, chloride ion, your Cl. You have your hydroxide ion. So this set looks a bit weird. This set looks a bit weird because usually you have 2 guys and you have 2 girls. All right? 2 guys and 2 girls. Now, there's only 1 guy. And then there's 2 girls. Weird, isn't it? Weird, isn't it? But don't care, we just do whatever we do. We do whatever we do. So B, during the electrolysis, which ions, they want everything, move. Chlorine and chloride. Chlorine is the gas, Kavi. Chlorine is the gas. We say chlorine gas, but chloride ion. That's the name difference. So which ions move to the anode and the cathode in both sets? Who goes to the anode? Guys, anode is what charge? Anode is positive, right? So positive will pull who? Hydrogen or these 2. Who goes to positive? Who goes to positive? Who is attracted by the guy? The girls, right? The girls, right? Okay. Positive, negative, negative. Right? Not hydrogen, Kavi. It should be hydroxide. Okay. Hydroxide ion and your chloride ion. Can? What about cathode? Cathode is negative. So who goes to cathode? That would be your hydrogen ion. Look at this. They want ions. So I'm going to list down everything. If they say who will be discharged, means kicked out, I only choose 1. Now they don't want you to choose. They want to ask what is the gender that goes there. All the girls will go to anode. All the boys will go to cathode. Are you okay? Are you guys okay? Are you guys okay? Just like up there, guys, this is just like up there. So state the products formed at the anode during the electrolysis of 1 mole decimeter cube. Okay, so if this is concentrated anode, concentrated, who will be chosen? If this is concentrated, high concentrated, very salty, which one would I choose? This is situation 2, right? Situation 2, right? Situation 2 will choose who? Situation 2 will choose who? Hydroxide or chloride? Which one chosen? Which one chosen, guys? Which one chosen? Is it hydroxide or is it chloride? Yes, chloride. They want the product. They want the product. So we don't write chloride ion. We write chlorine gas. Okay. If they ask for the ion, then we say chloride ion. But they are asking for the product, then we say chlorine gas. Can you guys okay? Chlorine gas. Chlorine gas. Yes, Kavi? No means no question or you don't understand. See? Why? What's up? What's up? You don't understand this? You don't understand this? We choose the higher one, remember? We choose the higher one. Situation 2 what? Situation 2. Situation 2. Instead of choosing the lower one, we will choose the higher one. Remember? So in this box, do you see chlorine? Yes, so we choose her. We will choose her. We will never choose something so high here. We will choose this three. If they exist. So in this case, they do. They exist. So I choose chloride. I choose chloride. Get that? Get that? Understand that? So you see, this is the difficult part. That's why I say, guys, you understand doesn't mean you know how to do. You need practice. This part is a lot like maths, right? Just because you understand maths doesn't mean you can do. You need practice. Okay, so what about 0.001 mole decimeter cube of hydrochloric acid? Who will be chosen then? This is just like, okay, just anggap this doesn't exist. Assume there's no 0.001 because this thing is useless. It means don't care. We don't care about the concentration. Who will be chosen then? Who will be chosen? Concentrated, we choose chloride, right? If this is no condition, then we choose who? No condition whatsoever, we choose who? We choose the hydroxide, right? We choose the hydroxide, but they want the product. They don't want you to write hydroxide ion here. What is the product? What will hydroxide become? What will hydroxide become? Yes, you will get oxygen gas. Okay. Charlene, Jella, you guys are really quiet. Do you guys understand? Do you guys understand? Do you two have no question? Understand? Really, Sure, Jella, you understand? Okay, good. Why too easy, is it? No question to ask, or you just don't know what to ask? Okay, so D. What is the product formed at the cathode during electrolysis? This one easy lah. There is no choosing here. There's only this guy. So hydrogen gas. This one easy. There's nothing for you to choose. There's only one. Hydrochloric and H2O. Yeah. Hydrochloric is actually hydrogen. Hydrochloric is hydrogen. Okay. So we're not going to do E because this is very long-winded. Okay. Guys, do you understand situation 1 and 2 now? If you can fully understand these 3 questions, that means you got this part understood. You got this part down, no problem. You can do it in exam. Do you have any question? Do you fully understand? For now, yes lah. If there's a table, you can. Like I said, guys, this is very easy to memorize. Just memorize the bottom 4, bottom 3. Okay, and free sex, no condom, but I'm okay. Okay, free sex, no condom, but I'm okay. Okay, so if you're really scared, then you write down the table in exam law. Write it out lah. Just in case you forgot. Okay, guys, can you please jump back to page 9? Can you please jump back to page 9? We are going to look at situation 3 today. So you see, we learned situation 1, right? We just choose the lowest guy. We choose the lowest girl, settle. And then we have situation 2. We choose the lowest guy, same. We choose the slightly upper girl, which is chlorine. Like I said, guys, even if you follow your normal SOP, you say, sir, I don't care, I just choose the ugliest girl. You still get half of it correct. You still get half of it correct, right? Situation 3 is what we are learning today. Okay, guys, let's look at situation 3. Okay, what is situation 3? Situation 3, okay, can you please add solution here? There's a missing solution here. Right, so what is situation 3? What is situation 3? Situation 3 is when the electrode is the same as the metal here. Okay, what do I mean? You see, this water inside here is silver nitrate, right? Silver is the guy, nitrate is the girl. Silver is the guy swimming inside here. And then these two sticks happen to be silver. You see, in situation 1 and 2, in situation 1 and 2, we just use, if you go back to situation 1 and 2, carbon. Okay, carbon means your pencil lead. Carbon is your pencil lead. Okay, carbon. What else? Carbon. Okay, whenever you see carbon, that is confirmed situation 1 and 2. Carbon means you don't care. Whenever you see carbon, you see, you might say, sir, you didn't mention this last week. Yeah, because carbon you can ignore. Whenever you see carbon, just ignore. Don't need to care about carbon. But now silver, we need to care. Silver, we need to care. You see silver, right? Or you even see, if you change this to, I see this is carbon, copper, right? But if you change this to copper, this two stick you change to copper, copper. Now this is situation 3. This is situation 3. You might say, sir, any difference, man? Any difference? Yes, there is a difference. Okay. Right. Before we learn this, let's do our normal SOP first. We do our normal SOP first. So what word do you see here? What is the word I told you to add just now? What is the word you see here? What is the word you see here? What is the word I ask you to usually circle? Yes, H2O. Solution. And then you cut. Plus, minus. Okay, can So, plus, minus. And then we just list down all the guys lah. 2 guys swimming in water, silver and hydrogen. 2 girls swimming in water, nitrate and hydroxide. Okay, if we do this the situation 1 way, the most original we learn, what do? We just choose the ugliest guy. Guys, who is uglier here? Silver or hydrogen? Who is uglier here? Yeah, silver. Ugliest, the ugliest guy. And according to situation 1, we just choose the ugliest girl, isn't it? Okay, this is normal SOP. But in situation 2, just now the chlorine one, we choose slightly higher, isn't it? There's a little bit of exception. Situation 2, when it's concentrated, we choose slightly higher. Situation 3, guys, pay attention, Pay attention. Situation 3, I choose neither. No girls will be kicked out here. No girls. Right? But instead, guys will jump in. Okay, what do I mean? Okay, what do I mean? You see, I have silver ion swimming in water, right? I will get kicked out at negative, right? Because positive goes to negative, right? I will start to see silver stick here. Can you see silver color? Can you see silver color? I will see silver stick here. And then usually it's the girls that goes here and get kicked out here, right? But now silver will jump in instead, because now this stick is silver. This stick is silver. You kick away one silver is going to come in. It's like you kick away my brother, I will replace it with another brother. You kick away my friend, I will replace my friend. Because they are both silver. They support each other. You kick my friend away, I will jump in to support my friend. So silver, 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 silver. So instead of girls jumping out, kicking out, the guy will jump in. So nothing to do with the girls. The girls have no business here. No business here. The guys will jump in. So guys, I have a question here. If the silver keeps jumping in here, what happens to this stick? Yes, the guy will move. What happens to this stick? I have silver jumping in, jump in, jump in, jump in, jump in, jump in. What will happen to this stick here? What will happen to the stick? Yes, it will, not to say kosong lah, it will become thinner. It will become thinner. It will become thinner. Instead of thick like this, they will slowly become thinner. Guys, this is what we say. This is what we say, corroded. This is what we call corroded. Terhakis. Corroded. What's corroded? What? Corroded means the thing got thinner lah. Right? Corroded. Instead of seeing bubbles, girls got kicked out here, the guys will jump in. Now this thing got smaller. Corroded. So this is quite special, guys. This is quite special. Okay? But if you tell me, sir, I don't care. I don't care whether it's situation 1 or 2 or 3. Everything, I'm going to choose the ugliest guy and the ugliest girl. Sure, go ahead. I'm not blaming you. Because this part is really difficult and you say you are lazy, you just want to choose the ugliest guy and the ugliest girl, go. I'm not stopping you. I am not stopping you. But I do have to say this. Okay, you might say, sir, why do we need to learn situation 3? What's so special about this? You see, this situation 3 is actually quite special. Situation 3 is actually quite special. Why? Okay, can you please flip to, there you see, silver deposited, silver electrode dissolved. I don't like to use the word dissolve. I like to use the word corroded. Silver deposited, silver corroded. Okay, can you please go to page 11? Situation 3, we apply it in 2 situations. Number 1 is your purification. This is for situation 3. And electroplating, situation 3. Okay, what do I mean? Okay, let's talk about electroplating first. Do you know what is electroplating? Guys, do you know what is electroplating? Electroplating means I use a metal and coat another metal. I balut a metal with another metal. We call it electroplating. What's that? Okay, guys, you know your keys? Your kunci, okay. Your keys, if you realize something, your key is originally silver. It's originally, not to say silver, silver color. Your key is originally silver color. But do you notice something? The more you use them, the silver color will start fading away. And then the part of contact, the point of contact where you slide in and out of the lock, the part turns yellow. Have you noticed this? Your key, after using it for like years, it will start to turn yellow. Why? Because the outside layer, the silver color layer is no more. What is that actually? Okay, your keys are, let's say this is a key. Okay, your keys are made from brass. Do you remember what is a brass? You learned this in alloy last year. Brass is actually yellow, right? But you see, brass is not strong enough. It's not they don't tahan corrosion very well, because brass will just rust. All your keys are black. Oh yeah, the black one is the oxidized brass. Your brass oxidized will turn black. You see? So what do? They will coat it, they will balut. Okay. They will balut this thing with a layer of zinc. They will balut this thing with one layer of zinc to protect your keys. So originally, if your keys are new, it looks silver because of the zinc. They don't call it with silver lah. I don't think your key is so rich they put silver there, so they put zinc. Right after using it for long, then you see the brass. Okay, so guys, let me ask you if you want to coat a key, do you put your key at the anode or the cathode? Do you put it at the positive or the negative? You want things to stick on your key. Where do you put? Do you put it here or do you put it here? If you want to coat your key with silver, do you put it here or do you put it here? Which one is the sticking part? Which one is the sticking part? You see, cathode is the sticking part, right? You see, silver sticks on it, right? So what do? You put your keys here. The thing you want to coat, the thing you want to electroplate, you put it at the cathode, which is like this. You see, if I want to coat my spoon with silver, I put it at the negative. So you see, now the silver will stick here, and then the silver here will jump in, and this thing will get corroded. Understand all? So you see, situation 1, 2, 3, 3 is the most useful. 3 is the most useful. And number 3, we can also use it for purification. Okay, what is purification? If let's say you have a piece of metal, this is 80% copper. This is 80% copper. You want to just extract the copper. You want to get rid of the 20% of impurities. What do? Now I want to pull things out. This piece of impure silver, let's say you have a piece of impure silver, do you put it at the cathode or do you put it at the anode? Do you understand my question? Just now, I want to coat my key, right? I put it here. If I want to coat my key, I put it here. If I want to extract my silver, I want to extract silver from a piece of not pure silver, where do I put it? I want to draw things out. I want to take things out. I put it at the anode, right? Can you see the silver coming out? So that's the meaning. If I put a piece of impure copper here, let's just say here, if I put a piece of impure copper here, I put a piece of pure copper here, the copper will come and stick here, the copper will jump into the water. Remember? So the copper keep jumping in, only copper will jump in because they are brothers, what? You see? Copper. So the copper will jump. And then now this thing is corroded. Now you are left with the impurities. These are the non-copper. These are the things we don't want. We only want copper. And if you do this for long enough, this thing will be coated fully in copper, as in like really thick. I successfully take all the copper out from here. Do you understand this? So your situation 3 is actually quite useful. We use it to extract stuff, to purify metal. We use it to electroplate metal. 2 jobs here. Okay, 2 jobs here. Any question? Any question? Guys, any question? Impurification supposed to be purification, because I'm trying to purify this impure copper. So why is it called impurification? I'm trying to purify it, but you get what I mean? I'm trying to purify copper, so this is called purification. Can you understand You understand what I'm trying to say here? Okay, so this is what you need to know. Okay, this wastewater you can ignore. So what we are learning today is your situation 3. Is your situation 3. Okay, I will not choose any girls. And where do we apply them in real life? Right? Situation 1 and 2 they're actually not very useful. 1 and 2 is just for learning for fun, but 3 is really useful in terms of real life. Right? When it comes to real life application, 3 is the most useful. Can this is all you need to know for now. This is all you need to know for now. Okay, go home and digest this yourself. Okay, Kavi? Okay, digest this yourself. The rest of you, Charlene, Jella, you two are the quiet ones. Do you guys understand? Do you guys understand? I hope it's a yes. I hope your silence is fully understood. Yes, I'll take your words for it. Okay, so guys, I hope we learned something new today. Okay, so next week, try not to be so blue. Okay, too many holidays, like you guys. That's why you feel so blue right now. All right, so have a happy Wednesday, guys. Have a happy Wednesday. I will see you soon. Yeah, sure. Go home and practice more. Go and do the exercise. Okay. I will see you soon next week. Okay. Have a good one, guys. Have a good Wednesday. I will see you soon. Take care. Bye bye.